So for today, you're going to be learning about how trig can be done completely differently. You just did trig, and your first time you did trig, the first time it was just like this. So let's kind of walk it back up from like normal trig, where you do sine is opposite of hypotenuse, right? Okay, so if it's in a right triangle, and this is, let's say, 5, and let's say this is 20 degrees. Can you remind yourself how to set up a little equation to figure out the hypotenuse? There's only one logical function to use here, because you've got the 20 all sitting out there. So what do you say? Is it sine, cosine, or tangent? Say it. Sine. So sine of 20 equals what? Opposite of hypotenuse, so therefore what? 5 over h. And you could solve that for h pretty easy? Alright. Now you might be like, well, I don't know what sine of 20 is. I don't expect you to. Which ones out of would I expect you to know? If I said figure out sine of this angle without giving you a calculator, if I had changed this to some other number, which one do you think you would know? Well, quick reminder, you do know when it's a 30, 60, 90, you do know the sine of 30. And you might be like, but I don't have that memorized. I actually do have that one memorized, but I don't expect you to have it memorized, but I expect you to be able to do this. Everybody make the classic 30, 60, 90 triangle. These are going to get used so many times, even in this unit called identities, which is what we're starting now, trig identity. It always comes back to these basics, like 1, and then what are the other ratios? I mean, 1 goes with... Catherine, you got this?
It goes 1 and then the square root of 3 at the bottom of 1.
Yep.
And then 2 special.
And you can do this in any order you like, and I like to say it goes 1. It's as easy as 1, 2, 3. And I get the smallest one, and then I get the biggest one, and then I go to the 3. And that way it's 1, 2, 3, you know, except it's square root of 3. So, all right, cool. And now, do you get from drawing that, I could ask you sine of 30? What is sine of 30?
1 over 2.
It's 1/2. I don't need a calculator for that. What's cosine of 30? Remember, this is the 30. Yeah, root 3 over 2. What's tangent of 30? TOA, it's opposite over adjacent. It's 1 over root 3. Good. And do you get, I could do the same exact thing with 60? Let's say sine of 60, and that'd be root 3 over 2. Cosine of 60, tangent of 60. The ones that I can't do from this are like 90, though. Do you get, I cannot take the 90 and go, what is the sine of 90? It doesn't work. This way of doing that doesn't work. So how did we find the sine of 90 before? Well, we remembered that 90 was here. And we also learned this strange system called radians, right? So that's pi over 2, and it's also 90. And what's the sine of 90? Well, you've got to know these. There's 4 points. Everybody make the 4 points that are on the unit circle. Because when you know that the answers are 0s and 1s and negative 1s. So pi over 2 is up there, and it's at 0, 1. Now I can do sine of 90 a completely different way. I'm not doing opposite of hypotenuse anymore. All right, did you have 0, negative 1, 0, and then 0, negative 1, and then 1, 0. That make sense? Okay, now if I'm going to ask you what sine of 90 is, here's 90. Sine of it is the y of it. Sine is y. What's cosine? X. And what's tangent? Y over x. And I know you probably just memorized them, but let's say you forgot them and you're like, I can't remember, and I'm on the test. You would draw this. And you go, this is x and this is y. And this is, well, in the unit circle, it's 1. And then you'd go, sine is opposite over hypotenuse, and you'd be like, oh yeah, sine is y because it's the opposite over hypotenuse. right? Okay, now I want to remind you, because we're going to use this later today, that this is technically the radius. And I said it's 1 because I was assuming it was in the unit circle. Do you get not all circles have a radius of 1? So technically sine is y, but technically sine of theta is y over r. And it just happened to always be that r was 1. You think r will ever be forever be 1? No. We're going to sometimes change it up and go, r isn't 1 this time. So remember, sine is y, but it's only that because r has usually been 1. So sine is really y over r. Would you please finish this? What is cosine and what is tangent in terms of y's and x's and r's? In other words, now you got to throw the r's in there. What's cosine and what's tangent? This is all a review so far. I know, it's been a while, it's been a long weekend. I actually had a fun long weekend, made me forget about math, which is kind of fun now. All right, so you should have said cosine is x over r, and tangent is still y over x. Notice how tangent doesn't care what the radius is? Okay. All right, so we've had a kind of a wide-ranging review now. So I need to go back to showing you why this, it always comes back to a right triangle. So everybody make a nice clean right triangle right there in quadrant 1, okay? Doesn't need to be exactly a 30, 60, 90, just kind of like, as long as it's in quadrant 1. And then this is x, and this is y, and if this is a unit circle, this is 1. Then we keep on saying that sine of theta is y, and cosine is x, and tangent's y over x. But what else could you say about this? Yes?
Cosecant is 1 over y.
Okay, cosecant, those other of the 6 functions. So sine goes with, you're putting an arrow here, it's not equal to, but it goes with cosecant. Let's make sure you remember those. Cosine goes with secant. And tangent goes with cotangent. But I'm not going to make you memorize them as like, you know, r over y. I mean, I could. Sine is y over 1, so then cosecant would be 1 over y. I'm going to just say, as long as you know sine, cosine, and tangent, then you can say, I'm not going to do cosecant. I'm going to do sine, and then I'm going to flip it. I'm not going to do secant. I'm going to do cosine, and then I'll flip it. All right, so everybody please figure out what cotangent of theta is by not doing cotangent. What's cotangent? So ask her, you didn't do cotangent first, did you?
No.
What did you do?
I did tangent.
And what was tangent?
Tangent was y over x.
But just not smart enough to know the answer isn't y over x, so what is it? The answer for cotangent is not y over x. It's x over y. There you go. Yeah. All right. So there's your final answer. Raise your hand if you feel like you get that. Okay, good. Then, what's the new stuff, server? We've done all of this before. Okay. Would you agree that in a right triangle, a squared plus b squared equals c squared? Right? Okay. So then, use x and y. But even better, y isn't y. Y is which function? Yes?
Sine.
Sine. Now this feels weird to be putting a sine on the side of a triangle, but if sine is y, then y is sine. You know, like I can replace the sine with a y. So then what can I replace the x with? Cosine. And so, instead of a squared plus b squared equals c squared, now I can say sine squared plus cosine squared is equal to 1. Now I'm putting those squareds in a weird place. You don't, when you say sine squared, you don't go like this, because doesn't that look like the angle is being squared? You don't do it this way. You put the squared on the sine, not on the angle. So see how I wrote that sine squared? I'm going to make it really, really clear. I don't do this. That is wrong. I do this. That's sine squared. That's saying take all of sine theta and square it. Now you could technically do this. If you write that out, I wouldn't mark it wrong, but it's kind of clunky. Wouldn't it be easier to save the parentheses and just put the squared right there? That's what you do when you're good at this. If you really want to put parentheses around it and say squared, I won't mark it wrong. I think you'll get sick of it after a while and you go, oh, okay, fine, I'll put the squared there. Okay, so sine squared plus cosine squared is equal to 1. I saw like one of those nerd t-shirts, and it said, I think you're sine squared plus cosine squared. I think you're the one. Get it? Okay, anyway. All right. So that's equal to 1. So then here's another fact. If that's equal to 1, then this is going to mess with some heads. Then what's sine squared equal to? Just sine squared. Yes?
1 minus cosine squared.
Yep. Everybody please write this one down. Sine squared theta is equal to 1 minus cosine squared. And this is the beginning of a huge list of what are called identities. Identities are facts. Like I am David Server. That is my identity. Okay? So when you see me, you could replace that with David Server. That's me. I'm the same exact thing. Okay? So if you see a sine squared anywhere on a math test, you can replace it with a 1 minus cosine squared, because they're equal. They're the same thing. They have the same identity. Would you agree that in the United States, if you have $1 and I have 4 quarters, we could replace the one with the other because they're equal. Okay? They have the same exact value. Okay, so why are you going through all of these mental gymnastics, Mr. Server? Well, a typical question down the road is going to say something like this. I actually wrote one down. I just want you to see how crazy looking these things are. What if I had cosine squared theta? You do not have to write this down. I'm just trying to show you an example of what a typical problem looks like for today. This is not actually for today. This would be a little too advanced. But they say, simplify. And really, this looks incredibly intimidating until all of a sudden it's not. And I bet somebody can do this already. So Jack, what would be just one thing, don't tell them the answer, but just tell them one thing that you would swap out and you'd say, I'm going to replace this with that. You distribute, okay. And you can, it does follow the math rules like that. But then you'll have cosine sine in one clump. Like you'll have to have, cosine times 1, of course, is just cosine squared. But then the cosine squared times the sine squared, that's kind of clunky, and no, you don't want to distribute it. All right. Kira.
You can change the 1 minus sine squared theta to cosine squared theta.
Yes, we can replace this because we just learned that a second ago, that 1 minus sine squared was cosine squared. Now you might be like, I have to memorize that? Not really. Here's how I'd think it through. I'd go, I know something about this. I remember there's something about sine squared and 1. And then you remember the main statement, which is sine squared plus cosine squared equaled 1. And you write that down for yourself. That's a fact you can depend on. Sine squared plus cosine squared is 1. And then you can go, how could I rearrange it so I have 1 minus sine squared? Well, I could just subtract sine squared from both sides. Minus sine squared. And then that's gone. And I have cosine is 1 minus sine squared. Okay, that's how I get cosine squared. Cosine squared can go right here. And then all of a sudden, I bet somebody is again smart enough to probably put this together. Come on, you can do this. Yes? Okay, so you put this together and you made cosine to the 4th. Because cosine squared times cosine squared would be cosine to the 4th. Over sine to the 4th. And can you finish it? I kind of wish this problem was upside down. Because then I think somebody would have got it.
Is it cotangent?
It is cotangent. Because if it had been upside down, you realize it is tangent. And then since it's upside down tangent, then the answer must be cotangent. Cotangent to the 4th of theta. Whoa, if you got lost right there, it's because you didn't recognize that it was just sine over cosine. And that's one of those things you're already supposed to know. Don't you already know that sine over cosine is the same as tangent? Remember that? Sine over cosine is tangent? Y over x? Yeah. Okay, so then if I make this to the 4th, does that still work? Yeah, this would just be tangent to the 4th. And then this is just upside down of that. So it's upside down of tangent, which was cotangent. All right, I know that's a lot. That's a lot. So what do you actually have to walk out of your knowing today? You have to walk out of your knowing. I'll answer those questions in a moment, but I'm trying to get to the point. That if sine squared of theta plus cosine squared of theta equals 1, then from now on, whenever you see a 1, you could put sine squared plus cosine squared. They're equal. At the end of the year, I have a giant number 1. And there's so many ways that you can write a 1. It'd be kind of fun to show a kindergarten teacher who teaches kids how to write a 1 and what a 1. That down the road, they'll be learning that this is 1. Sine squared plus cosine squared. It's 1. Same exact thing. So as I squared is negative 1, but then if I want that to become positive 1, it'd be squared. So that's I to the 4th. That's also equal to 1. All right, so there's a whole tons of things that are equal to 1 that are kind of cool that a typical kid learning it for the first time would they'd never have a chance to understand it. But it's true. It's equal to 1. So whenever you see sine squared, what can you replace it with? Remember that you can subtract. And you can say, well, sine squared then is 1 minus cosine squared. Do the same thing with cosine if you wanted to. And there's one more thing you can do with this, and I still will get to those questions in a second. But there's one more thing that you can do, and this is important. So everybody take a second and write this down, and then everybody divide it. Take take all of those and make a fraction bar underneath it. Would you agree we could put a 1 underneath them, and that would be fine? Okay, but we're not gonna. But we're gonna divide everything by cosine squared. if I decide to do something to one side of the equation, I decide to divide by cosine squared, I can do that as long as I do it to both sides. So there, I did it to both sides, I distributed it on both sides, and there we have it. And then this is another identity statement. The original one's in black. The one that results is, who knows what sine over cosine is? Say it if you know it. Tangent squared plus what's cosine over cosine? 1 equals what's 1 over cosine? Secant. We'll get better at them. You got to remember that cosine and secant are the sisters of each other. So that is another identity statement. The original one was in black here. This is another one you can trust. You know from now on that if you see secant, you're going to replace it at tangent squared plus 1. And I have a snappy saying for this one. I'm not the originator of this one, I'm the imitator. The one with the tan is what you seek. One with the tan, get it? Now in Minnesota, not many people have a tan nowadays, but people like a tan. I have evidence. People are willing to even spray on a tan. They're very willing to possibly give themselves radiation to get a tan. So people like tans. So the one with the tan is what you seek. Is just a dumb little saying that you could use to remember that. And the last one is if I had, instead of dividing this by cosine, if I had divided everything by sine, then this one would have been sine over sine, which is 1. This would have been cosine over sine, is with the cotangent, because cosine over sine is cotangent. And then the last one would have been 1 over sine, which is cosecant, and I have a snappy saying for that, you can imagine, too. 1 with the tan is what you seek. 1 with the cot, and on a nice blizzardy day, this works pretty well, is not what you seek, but they are cozy. I know, it's a stretch. 1 with the cot is cozy. There are 3 facts that you can use on your next test when you are faced with questions like I showed you a little bit ago, where you got this crazy set of cosines and sines, and sometimes they're squared and sometimes they're not, and you have to simplify it down. But one of the ones that's the most important is that tangent is sine over cosine. So I'm going to give you a nice complete list now. I recommend you start a blank notability doc. Make this your master list. Okay, make yourself a clean notability. Serious, really strongly recommend. All right. I'm going to start with 1 equals sine squared plus cosine squared. And then I divided everything, you remember that? And then it was the 1 with the tan. And I had divided everything, by one of the other functions. Is what you seek. And then I have the 1 with the cot is cozy. And yes, I'm aware I rearranged them to put the 1 in the front, and that's fine, because it just makes the saying sound better. And those 3 are all about a squared plus b squared equals c squared, so those are called the Pythagorean identities. Okay, you also have to know this set, and that's that sine, and not squared, just sine, is 1 over what? You should know this. What's sine? 1 over, yep, cosecant. Cosine, in your master list, we're almost done. Cosine's 1 over secant. And tangent is 2 things. It's 1 over cotangent, but it's also sine over cosine. And remember then that cotangent would be the flip of that. And so, kind of like side note, it just follows from it, but it's also true then that cotangent of theta would have to be the flip of this, and therefore cosine over sine. All right, taught you everything you need to know to be able to do tonight's homework. I'm going to take a step back and now answer a question. Did you have a question about this?
Oh, I had a question about the cosine.
Cosine.
To the fourth over, of theta over the sine to the fourth of theta.
Yep, and notice that these powers right here, they can be any power you want. They can be the first, second, third, fourth, and they'll still be the same function. So like cosine over sine is like sine over cosine, except it's flipped. And sine over cosine is tangent. And so since it's flipped, that made it cotangent.
With the fours kind of like cancel out or something.
Nope. Nope, you don't want to cancel them out. I get what you're saying, but the fact that something is squared doesn't just cancel out in normal math either. Like, would you agree if I had 4 squared over 11 squared? Maybe you don't know this. That does not reduce to 4/11ths. You don't just cancel those squareds. That wouldn't be true. Okay, so nope, you can't cancel off the powers that are on them. I mean, 4 squared is 16 over 121 is not the same as 4/11ths. Yes?
For another identity, can you have sine squared theta over r plus cosine theta over r equals r?
Yes, and this brings up a point that you can have a million different identities because you can replace this with that and you can replace that with this, and some of them are just like really useful and some of them aren't. It's kind of like we could make a tool that would do this weird thing, you know, for my toolbox, but I just almost never use it. Like a tool that allows you to drill holes upside down if you only have a ½ an inch to get underneath this, and somebody might even make that tool, but I don't need that tool. So these are the tools that we need right there so far. Now you'll have a few more that you have to learn how to use, but these are the biggies. Okay, so let's actually get to some homework on this and let's see if you understand how to do that. Pause for a second while I get there. Okay, so this is a good starter page. This is not meant to be the homework technically yet. This is meant to be in class, but we are in class. So, and they'd say, verify the identity. That's a typical question. What they're asking you to do is to simplify it down and show that this really is equal to 1. Is cosine times secant really equal to 1? And you can't just say, yep, it is. You know, like, because I don't want to say always, but we almost always give you something that's true, but you have to prove that it's true. It's not just saying, yeah, that's true. And I can't even look at that and go, yeah, that's true. I got to think it through, and therefore you want to show me your thinking. So cosine, is there anything like easy to replace cosine with? Well, I'd rather replace secant with something. What could I replace secant with? Yes?
1 over cosine.
Yeah. Secant is 1 over cosine. Because they're sisters of each other. And this is cosine. Oh, I see what we're doing here. Cosine times 1 over cosine. And what's that equal to? You're not done until it's a fact. 1 equals 1. That was 1. So now 1 equals 1. I proved it. One of your sides needs to stay exactly the same. Like, notice I never changed the 1. And if you can manipulate the other side until it eventually turns into a 1, then you've proved it. All right, let's look at this one. Is this really true? My advice to you, of the two sides, take whatever is more complicated, and I'd say having a fraction in it is probably more complicated, and manipulate the more complicated side until it turns into the simpler side. So I'm going to leave this alone over here, and I'm going to manipulate this. So, cosine, one of the best things you can do on these is to just spread them apart over sine times sine. Do you agree that sine squared means sine times sine? You with me so far? Because cosine, sine squared is sine times sine. Okay, now what's this? What's cosine over sine? And couldn't I just put a 1 on top over here? Isn't it timesing by 1 okay? Sure it is. So look at this. And if you're not good at these yet, you got to get good at them, because how are you going to just like figure that out? You got to recognize it. Oh, cosine over sine. That's like, is that tangent? Is that tangent? Cosine over sine? It's cotangent. So I have to replace this with cotangent. And then what is 1 over sine? Is that on your list of things you should know? Yes, it is. That's one of those flippin' sisters. It's the sister function. And what is the sister function for sine? Cosecant. So now I've replaced this with cotangent and this with cosecant. And then I just kind of take a breath and I look back at what they had. And oh my gosh, that's pretty much what they wanted, but I just have them backwards. You know, cosecant's supposed to be first and cotangent's supposed to be second. So then I do reverse them, because it's allowed in math for you to reverse these two. Because why? Because you have to have exactly the same thing on both sides. And this, notice, I never touched it. I just brought it all the way down. That is a identity problem. These are considered the hardest thing on the ACT. At least one of the hardest. This type of question is so hard it isn't even on the SAT. The SAT test doesn't go into identity trig. The ACT does. And so there's typically 4 hard trig questions on the ACT. You know, last unit we did, that'd probably be like 1 from there. There's probably 1 from this unit on the ACT. Okay? So this is like getting into like, there's 60 questions on the ACT. The very end ones, like 50, 51, 52, all the way up to 60, those are typically the hardest ones. There'd be a lot of times there's a question like this in there. So you're learning something that's still valuable on the ACT, which is cool, which means that that ACT Corporation's goal is to try to prove that you're ready for college, and that means that you need to know this type of trig for college too. All right. Did I prove it? Yeah, when I got it to the end and they were exactly equal on both sides. That's how I proved it was true. All right, so these are great hints. Do the more complicated side. The reciprocal is the ones where, you know, sine is 1 over, that's what reciprocal means, right? Sine is 1 over what? Cosecant. And secant is 1 over cosine. You got to know those reciprocals of each other. And the identities. The quotient one. And the quotient one is sine over cosine. This comes up so often. In fact, I was going to pick one. I'd say that comes up more than anything else. What is sine over cosine? Tangent. So know that one. And of course, if you know that one, then you'll know cotangent. Because you'll just be like, I feel like I recognize that one. Oh, it's flipped. Okay. If you have unlike denominators, get common denominators. You'll see that a lot tomorrow. We'll talk a lot more about using common denominators. So, you know, that's why I was saying in the top 20 is that I wanted to make sure kids knew how to like add things like this. Because if you can't do common denominators when it's like this, how are you going to do common denominators when it's like this? 1 over sine theta plus 2 is equal to cosine over sine. And then you're like, well, I need a common denominator, and this one doesn't have a common denominator, so well, what would you do? Well, what you'd do is put this over 1, so it has a denominator at least. And then I'd times by the, not cosine, I'd times by sine. You see how now it has a common denominator? And now this side can be added together because they have a common denominator. All right, so common denominators are going to become a big thing. The next thing is use the Pythagorean ones. Sine squared plus cosine squared equals 1. 1 with the tan is what you seek. 1 with the cot is cozy. Okay, and then there's this tip. Conjugates. I don't have time today to teach you how to do conjugates, but it's going to be a really powerful way to do complicated ones. And if you ever get stuck trying to simplify one side, you can always start the problem over again and try to simplify the other side. Because sometimes you think that the one side's more complicated and I'll simplify that, and it just doesn't work. So then you got to be like, okay, quit that, go to the other side. Maybe I'll simplify that. All right, conjugates is the only thing that I haven't taught you. And I think it'd be better to do a problem together of your homework than to try to teach you that. So I'm putting off conjugates for a different day. Here is your actual homework. It says day 1, and let's actually do this first one on the left side together. I'd like you to figure out, first off, which side is more complicated? Okay, clearly the left side is more complicated, right? So then of the left side, what's something you recognize like, ooh, I saw that somewhere and I could swap it out? George.
Henry.
Sorry. Dang it. I don't know when that happened, but somehow. Okay, Henry, sorry.
The 1 minus cosine squared can be sine squared.
That can be sine squared. So, everybody, sine over sine squared. Am I done yet? No. I'm getting close, though. Do you remember me saying that one of the best things you could do is to break this up into 2 of them? Sine theta over sine theta times sine theta. My sine squared is really sine times sine. Fight it, Jack. You can do this. Okay. That's the same as that. So why did I do that? Look at that. Why did I do that? Yes.
Because then you can root the sine theta over sine theta.
Yeah, what do those turn into?
1.
1. Can I just leave nothing on top?
No, you have to put a 1.
Put a 1 up there. And then what's 1 over sine? Cosecant. Which is cosecant. See? Now, if you think of these as a puzzle, like, how could I get this to work? It's a puzzle that'll always work. And I say the word always, every now and then we give you something that's impossible, but it's really, really rare. Okay, so today there won't be any impossible ones. You can trust that they're all going to be true. It's just a matter of you got to keep playing around with it until you finally figure it out. Now, there's some people that like puzzles and some people don't like puzzles. But if you're going to get a good grade in this test, you're going to have to figure out some puzzles. All right. Jack, which side should I manipulate?
The left side.
The left side. Why?
Because there's more stuff.
Good. Is it more complicated? Could I go replacing cotangent with something? Yeah, but there's probably something I'd do first. I'd replace, I'm circling in blue here, cosecant minus 1. You didn't ever tell us a saying for that? No. Can you say any saying that I said that had cosecant in it? Like the one with the cot? Oh, yeah. Say that one.
1 plus cotangent squared equals cosecant squared.
Now notice, I'm just writing the fact down off that sheet I gave you. The one with the cot is cozy. So, do you get this has got a cozy in it? Cosecant. So, I'm going to manipulate this to make it look exactly the same. I'm going to put a -1 here, and then I go, oh yeah, I guess I have to -1 on this side. So I've manipulated my saying of truth, this identity, and now it says cotangent squared is cosecant -1, and that's the cosecant -1, so I can replace it with a cotangent squared. And then you get, I got a cotangent over a cotangent times a cotangent, because that's what cotangent squared is. So now I have cotangent on top over cotangent, cotangent is all equal to tangent. So they say. And now I can go cancel, cancel. And it's 1 over cotangent. And 1 over cotangent is tangent. It's a really classic mistake for kids to leave it just like that, though. Why can't I leave it like that? What did I tell you about the end of a proof? Yes?
It needs to be the exact same.
The exact same. So I replace 1 over cotangent with tangent. And tangent equals tangent. That's how you end a proof. This is clearly the same. Tangent is tangent. Duh. One side must never be touched. You can keep manipulating one of the two sides until you finally are equal. All right. That was not an easy one. I know. But you had to remember all of the old trig from last chapter. Remember me saying that that chapter was going to be repeated over and over and over? It will. And you saw some of that today, and it's going to just keep on happening. So if you had trouble with that last test, a few of you need to come in and take a retake on that puppy. I'll be here on Wednesday morning during Mass, and I'll also be here Thursday morning. And if you don't practice this, you're just saying, I want to fail this next test. This next test is complicated. I honestly think last test was more difficult. I don't think this is going to be as difficult. But it's a different way of thinking. So practice this, please. Do your homework. That's all I got for you for today.